Yeah. Hello, dear. Good evening. How are you doing?
Hi, how are you?
I'm doing great, dear. Thank you.
So today, I was trying to do the question 3 of,
From the course enrichment.
no, not that, part, the CIMC test,
Okay.
and I wasn't able to do it. So, I tried to do it at home, but I wasn't able to. Question 3C.
Question. Let me see. Is it from part B?
Yeah.
Just a second. I'll show you a solution. Please see whether you are able to grasp it or not. It's a question.
Part B, question 3.
Okay. Oh, yeah. Okay. In the last class, we discussed the part A and part B. Okay. Okay. I gave this as homework. All right.
Yeah. Because they ask you to prove it, but I don't really have I know how I can do it myself, but I don't know how to prove it so that the explanation is right.
Okay. Just a second. So the question is, suppose that Farooq swims faster than Ivan. Show that the length of the time between two consecutive instances when Ivan and Farooq cross is constant.
Yeah.
The length of the time between the consecutive instances is constant. Okay.
So they're trying to say like every time they meet, the time between every time they meet is always the same.
Yeah.
You have to prove that.
Okay. So here is the explanation. So Ivan and Farooq cross at a point. The sum of the distances that they have swum is multiple of 200 meter because we are very sure about the length of the swimming pool, which is 100 meter. So they are assuming the sum of the distances that both is multiple of 200 meter. And at every point where the sum of the distances that they have swum is a multiple of 200 meter, Ivan and Farooq cross. So both are 200 meter and 200 meter, which means multiple of 200 meter. So we are
Yeah.
already aware of these fact. So you have to write the fact in your solution.
Yeah.
Okay. And also in our question, they stated that thus between two consecutive instances, when Ivan and Farooq cross, their total distance increases by 200 meters. Can you follow this?
Yeah.
So two consecutive instances, when they cross this, it will increases by another 200 meter. And it is said that the speeds are constant. The amount of time taken for the total distance to increase by 200 meter doesn't depend on which particular consecutive crossings are involved. Can you follow this?
Yeah, I think they're trying to say that they're at the same speed all the time. So every 200 meters, they're going to take the same time.
Same time. So the time between two consecutive instances when they cross is also constant. So by this, we are saying that the time is also constant.
Oh, this is what I thought, like in my mind, but
Okay.
I
Yeah, no,
didn't
you don't
know
know how
that
to put it in the sentence.
yeah, you can't like put it as like it's no math. You don't need to add anything or
No,
anything.
yeah. You sometimes
Just
like it just explanation. Sometimes they just looks like some physics explanation. That's enough. You don't have to prove it like a math theorem. This itself enough.
okay. Yeah.
Shall we go back to the course enrichment? I think
Yeah.
in the last class I shared the tab row column for the parabola one.
Yeah, we stopped at the parabolas.
Okay. So what I thought of doing today is going through the exercises question, and also I want to discuss some important Olympiad problems from the parabola.
Okay. I did after class last week, I tried doing the exercises
Okay.
and I did the first two, but
First
then
two you were able to do it. Okay.
I was able to do, and then
Oh,
I didn't really understand how to do the others. So
others.
I
Okay.
stopped.
Okay. We'll discuss from there. What about the question number 3? Shall we discuss that?
Yeah.
I hope you're able to see my screen.
Yeah, I can see it.
Okay. So in the question number 3, the question is about the ellipse. So ellipse has the following locus definition. For any point P on the ellipse with foci f1 0, 3 and foci 2 0, minus 3, P times f1 plus P times f2 is equal to 10. And we need to determine the equation of this ellipse in the form of x square upon b square plus y square upon a square is equal to 1, where a is greater than 1. I mean,
Yeah.
a is greater than b. Okay. So what do you understand from this? Like x square upon b square plus y square upon a square is equal to 1, where a is greater than b. Like how do you draw ellipse for this? What will be the minor axis and major axis? Any idea about this?
So F1 and F2 are like the two middle points.
Okay.
Almost.
Okay.
Um, it would be like, let's say this was at foci 1 and this was foci 2 or something.
Okay.
And then you would draw an ellipse to that. Like
Okay.
this. That's all I understood. And they want the equation in the form x squared over b squared plus y squared over a squared.
Okay. So what will happen if I have a square underneath the x square?
You're dividing it?
No, I'm asking you, like, what do you mean by this, like x square upon y square plus y square upon b square is equal to 1? Where b greater than, what does it mean? Okay, I'll tell you this. So you do have two kinds of ellipse, Shan. Okay. So the first one
Okay.
is, I'll write the general formula of this. X minus h the whole square upon a square plus y minus k the whole square upon b square. You know what is h and k, right? Just a center. Okay. So if when you have an equation like this, you will have ellipse, like this, which means major part of the ellipse will be lie on the x-axis. It will be like this. In case if you have an equation like this, x minus h k whole square upon b square plus y minus k the whole square upon a square is equal to what? In this case, the y-axis is going to be the major axis. It will just turn this way. Do you understand the difference? So now you will call this, you will call the x-axis as, in this diagram, you will call this x-axis as vertex. And in the second diagram, you will call this y-axis as vertex. Okay. So what about the other axis? You will call the y-axis as co-vertex. And over here, you will call the x-axis as co-vertex. And center is going to be here, where the x-axis and y-axis gets to meet. That's going to be h comma k. And here also, here is the center, h comma k. So in the first diagram, you will have two focuses, right? Like here you will have focus 1, and here you will have focus 2. So when you have a square underneath the x, you will have focuses like this, f1 and f2. And when you have b square underneath the x, the diagram will turn into y-axis. You will have f1 here and f2 here.
Okay. Oh, I get it.
Yes, and also tell you where you will have the A and B. Okay, and this
Okay.
A is nothing but the length from the center to the edge, from here to here. This is going to be your A,
Okay.
and from here to here going to be B. And in this, the A is going to be from the vertex to the center. This is A.
Yeah.
The major part, that's going to be A. Always the major part will be A. Okay. So this will be B. The minor part will be B.
Okay. So A is always bigger than B.
Yes.
Okay.
So now you tell me which one is appropriate for this equation. X square upon B square plus Y square upon A square is equal to 1, where A greater than B. Which one is appropriate?
The vertical one.
I mean, here,
Like
the
this
first one, x-axis is major. Like you can see the elaboration like this.
Yeah.
And in the second diagram, y-axis is the major one. You can see the diagram like this. Yeah.
Yeah.
So this is, the second diagram takes place when you have b square underneath the x-axis. So if you look at your question, they also have the same results. X square upon b square, which means the appropriate one is going to be the option 2.
Yeah.
Clear?
Yes.
So 0, 3 will be here. 0, minus 3 will be here.
we also know that if you, like, let's say there's a point on the line P, that's what they call it.
Yeah.
That is when you add the distances from here, from foci 1 to foci 2, it's
Okay.
going to be 10.
Yeah. So here they're asking about the equation of the ellipse, which is in the form of x square by b square plus y squared by a square is equal to 1. So all you have to do is find the value of a and b. So how will you find the a and b value here?
Well, we can find the b value
Okay.
by, so let's say point P is like exactly in the middle, right? And
Okay.
it would be, the distance would be equal. So like PF1 would be 5 and PF2 would also be 5.
Okay.
And then if we have like a right angle triangle, wait, let me just draw it. Like it would be like this. And this is PF1 and I mean F1 and F2. So the point would be, so the distance between F1 and F2 is 6 because it just lines up. So this would be 6. And since this and this is 5 and they're equal, then if we draw a line in the middle, then it's going to be a right triangle. So then this is 3, this is 3, and this is 5, and this is 5. So then the middle part is going to, since it's a right angle triangle, it's going to be a 3, 4, 5 triangle, which is 4.
Yeah.
And so B is going to be 4. And I don't know how to do A though.
Okay. So you said that the middle part is 4, and that's gonna be b. What is a here? Can you draw the diagram and predict the a?
Okay, so this is kind of the ellipse.
I'll give you a clue. If this is your ellipse, from here to here, gonna be 2a.
Yeah.
So do you find the length from here to here?
Yeah, but we need the 2 points on both sides.
Okay.
So we don't know what this extra part is. Like, it's just...
Okay. I'll also give you a formula, like where you find p square is equal to a square minus b square. Okay. And what is
Okay.
that c? It's nothing but you have your, could you please erase your diagram, please? Yeah, okay, I would be able to. I'll tell you what is
Okay.
this c. Because now you don't have any information apart from the focus. So this is your ellipse. So this is F1, and this is F2, 0, comma minus 3, 0, comma 3. So C is nothing but the length of F1 to the center, length of F2 to the center. This and this going to be C. Okay. So C is just 3.
Yeah.
Right. So you know the value of C and you don't know the value of A square. Just keep that as A square itself. And you know the value of B. What is B?
4.
4 means 4. So by using this, you'll be able to find it's 9, 16, 25, A square is A is equal to square root of 25. So
A is 5.
So A is 5. So that is how we.
Oh, so then the equation would be x squared over 16 plus y squared over 25.
25, exactly. But we need to give it in this form. So you will write the equation as x square upon 4 square plus y square 5 squares.
Yeah.
Shall I erase the screen?
Yeah.
We'll move to the question number 4. An ellipse has foci minus c comma 0, which is f1, f2 is c comma 0. The locus definition pf1 plus pf2 is equal to 2 times a, where p is any point on the ellipse and a comma c is greater than 0. Solve the following problems which lead to the general equations of the ellipse. Let A1 and A2 be the endpoints of the major axis, as shown here. You'll be able to see it, A1 here, A2 is on the right-hand side. We also have to find what is the A1 and A2 is. And let B1 is going to be 0, comma minus B, and B2 is 0, comma plus B. B is greater than 0. These are all endpoint of the minor axis, which means these. Assume this is B2 and this is B1 Okay, so we have to determine the relationship between A, B, and C.
Yeah.
And we also have to derive the equation for the ellipse. Okay. That's good. So we'll go through this equation. A1 and A2 be the endpoints. We need to find the coordinates of A1 and A2. It's pretty simple, right? I have already told you this with the diagram. So A1 is nothing but the length of the major axis, like from here to here, it is A. From here to here, it is another A.
Yeah.
Because X is major axis. Excuse me. So here it's gonna be negative A comma 0 because it is in the negative x-axis. And this A2 gonna be positive A comma 0 because it is in the positive x coordinate. So
Yeah.
it's just negative A comma 0 and A2 is positive A comma 0.
Yeah.
And they gave the coordinate for the minor axis already. We need to determine the relationship between A, B, and C. So we are already aware of this. I gave you an equation which is C square is equal to A square minus B square, isn't it?
Yeah.
So that would be the relation for this.
Okay.
And what about the subdivisions B? We have to derive the equation of the ellipse. Okay. Okay, I'll show you the derivation. Okay, this would be a little bigger. I'll do it in a whiteboard because whenever they ask this kind of question in the part B, you have to give its full explanation. So when they ask you to derive the equation of the ellipse, you have to give the diagram also along with the derivation. Okay. So you know the basic diagram of the ellipse. So I'm not going to draw that again. Please keep that in mind. You have to draw the diagram as well.
Yeah.
So we are going to derive it from the distance formula. You are already aware of this. PF1 plus PF2 is equal to 2A. Assume this is equation 1.
Yeah.
Here, we will be elaborating this PF1 and PF2 with the help of the distance formula. So in the distance formula is x minus x1 the whole square plus y minus y1 the whole square. This is distance formula I said. So for PF1, assume this is ellipse. If I locate P over here, the F1 must be here, and F2 must be here. I'll connect it this way. Let's assume this is C comma 0 and this one is negative C comma 0. So this would be x1 and this would be y1. This would be x2, this would be y2. So if I use the distance formula, the PF1 is going to be square root of x minus c the whole square plus y minus y1 the whole square, which means y minus 0 the whole square. So for PF2, again, we will have x minus x2 the whole square plus y minus y2 the whole square, which is nothing but x minus of minus c. Minus of minus c will become plus the whole square and have y minus 0 the whole square is equal to 2a. Can you follow this?
Yeah.
I have just used the distance formula for elaborating this P1 and P2. That's what I did. So now
Yeah.
what I'm going to do, I'm going to take one of the part to the right hand side. So, okay, let's keep the green color on the left. It will be x plus 0 the whole square plus y minus 0 the whole square can be written as y square. And you have 2a minus of square root of x minus a the whole square plus y minus 0. I mean, y minus 0 the whole square could be simplified as y square.
Yeah.
So let's simplify this further by squaring both the sides to remove the square root. That would be much simpler. If you square both the side, squaring both the side will get the square will be removed, and here you will have whole square. And in the right hand side, it looks like a minus b the whole square, which can be expanded as a square plus b square minus 2a. Is it?
Yeah.
And also I'm elaborating this x plus c the whole square, which is a square plus b square plus 2ab. I hope you can follow the left hand side. In the right hand side, I'm going to expand using this. A square going to be 2a the whole square, which is nothing but 4a square plus b square going to be this. So the square root will be removed, which is x, I mean not a one. Why did I put it here? That's x minus c the whole square plus b square. So a square b square is done minus 2 into a into b, which means minus 2 into 2a into this. So 2 into 2a will be 4a. And b is this. So x square plus b square. So now let's simplify this further. You have y square here and y square there, but it can be cancelled out. And okay, you can also elaborate this. I'm just writing the left hand side as it is. In the right hand side, you have 4a square x minus 0 whole square will be a square plus c square minus 2xc minus 4a into square root of x minus c the whole square plus y square. So
Yeah.
I can cancel out x square c square, x square c square. Yes, can I do that?
Yes.
Please take a screenshot. I'll just erase this. Yes.
Yeah.
So now I can move this minus 2xc to the left hand side. So you have plus 2xc and 2xc will become 4cx. I'll just do it here. So it's going to be 4cx is equal to, I'm writing the remaining steps, 4a square is minus 4a square root of x minus c the whole square plus y square. Yeah. So let's take 4 as common from this. To do that, it's going to be a square minus a square root of x minus c the whole square plus y square. You have 4cx, this will cancel out. So you have cx is equal to a square minus a into square root of x minus c the whole square plus y square.
Yeah.
So okay, we need to do one small change. We just have to switch their position. Switch this and this. So when you switch, what happens? It becomes a square minus cx is equal to a times square root of x minus c the whole square plus y square. Can you follow?
Yeah, because you're just to bring it to the other side.
Yes, yes, yes. So now you have to square both the sides again to remove the square root. Okay. So when you square both the sides, what happens? This will be elaborated as again a square minus b square format. This would be here square root will be removed. It's y square. So if I elaborate this with the help of a minus b the whole square formula, I'll be having a power 4 minus 2a square cx plus c square x square in the left hand side. On the right hand side, I will have a square times x minus c the whole square plus y square.
Yeah.
Yes. So again, I can expand this x minus c the whole square. Here. So that would be a square times x square minus 2cx plus c square plus y square. I just wrote this expansion over here. I'm just gonna write this as it is, which is a power 4 minus 2a square cx plus c square x square. So now what I'll do, I'll just take the a square inside, I'll multiply with all the 4 attributes. If I do that, what I'll have a square x square minus 2 a square cx plus a square c square plus a square y square is equal to a power 4 minus 2a square cx plus c square x square. So now if we look at it, we have 2a square cx and 2a square cx on both sides, which will get cancelled out.
Yeah.
So maybe having a square x square minus
Plus a squared c squared.
yes, which means yes, yes, yes. This is plus a square c square plus a square y square is equal to a power 4 plus c square x square.
Yes.
Okay, I'll do this in the fresh page. Please take a screenshot. Done.
Yeah.
So now I'll have this a square x square minus c square x square plus a square y square is equal to a square minus a square c square. So I just took the a square c square from the left hand side to right hand side, and I took the c square x square on the right hand side to the left hand side. Just switch their position. Why to take the x square outside? If you take the x square outside, you will have a square minus c square inside bracket. A square y square, and from here also you can take a square outside, you have 1 minus square. Oh, okay, it's supposed to be a raised to it's a raised to so when you take a square from this, you will have a square times a square minus c square.
Yeah.
So now you divide both the sides by this. So what happens? A square times a square minus c square on